up until the current time, the primary search process for NEAs has been done from telescopes on Earth. We have had one telescope, well, there are a couple, and there's another going up shortly out of Canada, etc. Small space telescopes, but they're telescopes in orbit around Earth. So all of the searching that we've done for near-Earth objects has been done from an Earth environment, mostly from telescopes on the ground. Now, generally speaking, that has two big implications. Number one, those asteroids, and there are a lot of them, which cross the Earth's orbit and are therefore potential threats, which spend most of the time inside the Earth's orbit. In other words, they have orbits whose period is less than 1 year. Most of their time, their orbits are inside of the Earth's orbit. You can't really see them very well. You can only see them when that portion of their orbit that comes outside the Earth's orbit, so that you get a chance to see them at night. Most of the time, they're in daylight, and you can't look toward the sun. That's one problem. The second problem, so you have a very short period of time every several years when you have an opportunity to see them. The second problem is that even after you've found them, if they have an orbital period which is near the Earth's period, in other words, 0.95 or something to 1 year, then what happens is the opportunity that you get to see them only, it occurs it's a resonance kind of thing, so that only once every 7 years, once every 10 years, once every 15 years, you actually get a chance to see them. So your tracking accuracy ends up being a very episodic thing. You get a couple of years where you can see them, and then you don't see them for 8 or 10 years, and then you see them for another 2 or 3 years. Well, if your accuracy of tracking is critical in terms of when you have to launch a mission, when you have to make decisions. So what you'd like to have is, number one, an opportunity to discover these things more easily, and number two, once you discover them, you'd like to have relatively quick cycling of the tracking opportunities. Well, the way you do that is to put a telescope into a Venus-like orbit. Take a telescope and put it into an orbit between 0.7 and 0.8 AU, the distance to the sun. So if you think about Venus not being there, put it in a Venus orbit, right? Now that telescope is going to be looking out from the sun and see most of those, in fact, it'll see all of those objects which cross the Earth's orbit, but it will see them looking away from the sun, and therefore much more frequently. And because it goes around the sun at a higher frequency, I mean, I don't remember what what Venus's year is, but it's 200 and something days. So therefore, it's going to see these objects much more frequently than you would see them from the Earth, because it doesn't have this phasing problem. So the smartest way right now to both discover a very large number of asteroids which we haven't seen yet at all, and once you do discover them, to get good tracking data on them, is to put one or more small space telescopes. They don't have to be big, but small space telescopes in a Venus-like orbit looking outward to pick up all these asteroids which we're not finding yet.